So I titled my my presentation "GIS and Earth Observation: The Power of And." Hopefully, sort of during the presentation, it'll become clear why I've called that. One of the things that we have observed is that there seems to be, or there appear to be, sort of two different worlds, if you will. The ones of the GIS analysts and their data, and then sort of the ones who focus very much on Earth observation, and maybe more scientific data formats and scientific users of this Earth observation data. Not to beat a dead horse, but I mean our problems are global. In GIS, this is a typical sort of thing that we see, right? No one agency manages all the different data sets and data types that are being used to answer the questions of this agency. And and so we need to really collaborate and break through some of these barriers between individuals, between departments, and obviously at larger scales between national agencies and country boundaries. The weather doesn't stop at a country boundary. That's a very sort of typical example here. So naturally, this situation results in creating networks of people who work together, who share data, who use each other's data. So global networks, Group on Earth Observation is one example of a sort of a global network where sort of the individual pieces that you see around this geo here are themselves actually networks. So that's I guess a very familiar kind of network for everyone. If you look a little bit closer at a national scale, then what you see is that, for example, in the US, the geospatial platform can be seen as a network itself. In this case, you have federal agencies, actually state and local government agencies participate in this as well, and they all share their data with each other. At the federal level, some of the agencies have been assigned sort of the custodian role of some data sets. Those are considered national significant data sets, right? They're treating these data sets as an asset. They have very purposeful data management procedures and agreements around those data sets. And those are sort of the core of the national spatial data infrastructure. But then there's a lot of data being generated by individual agencies. There may be derivatives or maybe additional views or other kinds of combinations of these traditional data sets. It may be analysis, it may be forecasts, and so on. And obviously those are being shared between the agencies. Data.gov as an open data site connects to the same organizations, right? So from an organization perspective, now they have kind of at least two sort of customers, if you will, of their data. One is the geospatial platform, one is data.gov that has a broader open data focus. But agencies like NOAA, EPA, or NASA, or others, they participate in these it's the Weather Service interacting with a program like CEOs, whether it's the ocean data centers or the climate data centers. They're all sort of, they have a different role, different purpose. They may collect data of specific themes, different focus areas. But of course, this data is used and shared across an agency like NOAA. So this is a very nice, clean sort of picture of these networks at different scales, right? If you look at how NOAA's network actually is, it looks more like this, right? So what you see is that different data centers have set up data connections to other data centers, and not every data center is connected to every other data center, right? So if I start from, say, for example, NGDC in the center, I may be in luck because it's fairly well connected to others. If I were to start at maybe the IOCM sort of catalog and portal and so on, I'm not so much in luck because it only has a few connections, right? So that's kind of the reality of building these networks, and having to explain to users what they need to do to connect to these other networks is not really what they're interested in, what they're focusing. They just want to be able to answer some of the questions that they have to answer. And those questions are not how to connect systems and so on. Those questions are of economic nature, or national security nature, or maybe an environmental nature, like unit life. If you look a little bit closer into those sort of drivers of creating these networks, of creating these infrastructures, national security, their goal really is to make better decisions and make them faster, and ensure that whoever is involved in a disaster response, for example, has the same view, same understanding, and knows what needs to be done. Right? There's no confusion. Where is the fire perimeter? Right? Where are the evacuation routes? Where do we have sort of our staff stationed during an emergency like this? And these are law enforcement and other sort of agencies that need to work together. Sort of at an economic focus, maybe the focus is more on promoting innovation. Well, that means you work with startup companies that are not necessarily familiar with the geospatial technologies. So how do you make it easier for those groups to start developing their applications and innovation, and how do you then use that, etc. In an environmental sense, that's where better decision making and enforcing policy might be sort of important. And so, for example, the UNEP site focuses very much on reporting and showing a number of indicators. And the users of that UNEP site really just see those reports, those charts and graphs and so on. They're not using sort of the back-end technology and so on. Right? Those users do not use things like GML or Sparkle or OGC terminologies. That's for us, sort of the engineers of those systems, to understand those kinds of things and to make sure that the systems connect to each other. But for an end user, it really should be very transparent. The challenge is thus that we need to connect these networks and make sure that if a user is interested in some data, they're not only seeing their own worlds, their own universe, but they're also connecting to these other universes. Right, so that's kind of the idea of when we started working with the Geo and sort of the DAB group, Stefano and his team, to really connect the worlds of GIS and Earth observation, so that people could find things across each other without having to understand the sophisticated data formats like netCDF or HDF. And we started this about a year and a half ago now, leading up to one of the Geo events. And what we essentially have done is added the ability to use ArcGIS Online and connect to ArcGIS Online from within the Group and Earth Observation site. I'll show that in a little bit. And vice versa, we've made it easier for ArcGIS users to consume content that is found in Earth observation networks, if you will. And obviously, we're using some standard interfaces for that. And at the same time, we're making it such that the end user doesn't really have to know those interfaces. So while I start sort of ArcMap, because I'll show a little demo there. So I'll go through a few sort of quick demonstrations and explain how this really works. Right. So let me start with a very simple sort of geoportal server demonstration here. Geoportal server is a technology that my team at Esri have started to develop 12 years ago or so, when we started to implement these SDI. And since 2010, it's been released as open source, as a metadata catalog, essentially, that facilitates sort of discovery and access in these heterogeneous environments, right, across multiple networks, implementing standards like CSW, obviously, but also things like OpenSearch, or even generic search and XML types of interfaces that don't necessarily follow a specific standard or specification. So very simple. This is, I mean, obviously it should be common, especially if you spell something. You don't have to spell it, but properly. But there's some ways that you can change words and so on. So see here, so my site has a few sort of results, and that's great, but obviously there's more rainfall data available. And so, for example, I could look at ArcGIS Online and see what ArcGIS Online has in addition to my own site. Right, so now I've federated a search to ArcGIS Online, including my own site, and obviously ArcGIS Online has a lot more content, and so the chances of finding more rainfall data is actually a lot higher. As you can see, I have a number of these types of catalogs. Some of these are implementing sort of GeoPortal server itself. Some of them are implementing other CSW-based catalogs. The Federal Register doesn't implement CSW or OpenSearch for that matter. It implements its own specific interfaces. I wanted to connect to the GeoDAB here. Right, so that's essentially a CSW interface to the DAB. And it's going to return sort of a lot of results about rainfall that are available in the Earth observation network, if you will. Right. So the idea being that I can, as a user, I can easily connect to one of these other networks and find results that I might be interested in, without actually having to know the specifics of the profiles that are happening behind the scenes here. Right, so that's something that has been working. We've developed this over the last 8 years or so when we started doing this federation, and this works really well. It's very extensible, and it can connect to various different types of portals and so on. And by now it connects to things like YouTube. Right, so if I want to find some rainfall videos on YouTube, for example, well, I can do something there. Right, so that's the idea of this type of integration, of federation of content. Now that doesn't just work in this GeoPortal application. Right? We've started to develop similar capabilities for web application viewers. Esri has a technology called the Web Application Builder, and that is a framework where through a set of widgets and configuration, you build a viewer without programming. Right? So this is you assemble the necessary widgets that you would like to see, maybe a legend widget or maybe a layers widget. Right? So I don't have a lot of layers here on this precipitation one. And then what we have done is started to work on a widget that allows us to do the same kind of federated search. Right? So I'll do a search for rainfall here in ArcGIS Online, and I find some of these layers here. And if I am interested in the total annual precipitation, being in California, this is sort of a hot topic right now, then I can easily consume the service. Right? I don't know who the service is from. Right? I only know that I found it on ArcGIS Online, and I could switch to maybe a GeoPlatform with Gov, or let's see, we have a sandbox or GeoPortal server that I could use, and I'll find some results there as well. Right, so the idea is that I can very quickly build a map, a mashup, if you will. And so this is a widget that we're developing right now, and we'll make sort of available as open source as well, so that people who use the web app builder can easily consume it. But if I'm a desktop GIS user, I don't use a browser. I use ArcGIS Desktop, for example. And there we have enabled this same kind of discovery. Right, so this correctly here. So I do search for rainfall. I do it in our GeoPortal server sandbox, for example, and I find some results. I could then, if these are files that I could download, I could maybe download the file. If this is a map service, I could maybe view the map service directly in my desktop environment, and then do what you do with GIS. Right, so that's the idea of making it simple for users to find data, to use data across multiple networks. All right, so that's one aspect of this. Let's switch back over here. So another aspect here is to help users in the Earth observation network find GIS content that is being managed and created by sort of GIS users, and in our case specifically ArcGIS users. So what we have done here is actually extend the Group on Earth Observation portal to also be able to search ArcGIS Online content. Right, so in the portal homepage here, I can go to one of these ArcGIS, these Earth observation catalogs, and what you see there's an ArcGIS Online Esri sort of entry in that, and through this mechanism I could search for the same, so the rainfall, and do a search. And it's now actually accessing content that came from ArcGIS Online that is accessible and findable in these in this group of Earth observation portal. From here, we might be able to view the map, or open download the zip file that has the data in it, or launch a web application that might have been registered in ArcGIS Online, etc. Right. So the idea is that from both communities, we can connect to each other very easily, and make this sort of connect these two worlds of GIS and Earth observation in this sense. Now, what can you do with this is, for example, build little applications, and maybe very focused applications. And here's one where we may have downloaded a netCDF file with multidimensional data. In this case, water temperature over time and so on. And that netCDF file was then exposed as a WMS service through ArcGIS Server, and it exposes the time dimension and so on. And so what you get is a view of ocean temperature, and it would allow you to very quickly sort of switch from one sort of date to another date, and if the dimension is depth is included, it would allow you to sort of switch to different depths and choose the water temperature at different depths and so on. All driven by the data in this netCDF file, but exposed through WMS services. As an end user, I get a simple slider. I may get another slider that allows me to do sort of depth selection. I can animate this because the WMS service understands the time data in the netCDF and exposes that through this simple web application, etc. Right, so that's one example. Another example is we've obtained some data through the group of Earth observation from the global marine environment dataset, being sort of managed and authored from a number of different agencies. Auckland University actually hosts some of these data files. So we've downloaded those, again, sort of netCDF type data files, and expose those as a set of image services, and we can then do these simple visualizations. However, I could actually do a little bit of analysis. Right? So if I take, for example, calcite and depth, and I can then do what you might call a weighted overlay. Right? So I can say, well, I'm doing an overlay of the depth and calcite. Depth is kind of important, so with this 70% of the weight, and then I'll assign calcite for 30% of the weight, and I'll run this model, and now it's actually doing some analysis on the fly, right? So that as an end user, I don't have to know what's behind this anymore. I can do this on the fly analysis, and I can see the results of where depth is deep, right? Where is it deep, and where is calcite high, and that may, in the right combination, apologize, I'm not an oceanographer, that may help an oceanographer sort of understand sort of suitable locations or likely locations where coral reefs might actually flourish, if you will, right? So what are the different conditions? And so that's back to sort of why are people doing these things and why are they interested in data? As an oceanographer, I am interested in a number of different things. Right? So it might be these particular layers, it might be other layers. I want to very quickly go out to one of these networks, find my data set, expose them as services. Ideally, they're already exposed as web services, and then combine them in a model like this to do my analysis. That is what I'm here for, so to say. Right, so there's a few examples of how you can cut across different disciplines. This overlay application actually came out of the geodesign practice that has been sort of evolving over the last couple of years in the GIS community. site planning, right? So really coming more maybe from even an urban or sort of a park planning kind of discipline, but very easily applied to ocean sort of analysis and research. So the idea here is that many sort of users can connect to the different networks. If you look at it from an ArcGIS user perspective, this is what a typical ArcGIS user organization implements. Right? So they have a set of servers and databases. There is online content that they might consume. There's typically a portal, which might be in-house, or might be ArcGIS Online, so software as a service portal. And then there's different clients, different applications. And for these users, we're trying to make it easier at every of these layers to integrate with other networks, whether it's consuming netCDF or HDF in the desktop and exposing those as web services, whether it's connecting through these widgets that I showed or other sort of application technologies with other systems at this integration layer tier, or whether it's simply developing a web application that consumes services from elsewhere, or whether it's a desktop application. Right? So that's the widget framework that I showed a little bit, and so on. So that's very briefly sort of how ArcGIS users can actually benefit at different layers of the stack, if you will, of sort of increased interoperability and information and data coming from different networks. Now, so yes.
Martin, can I just ask a question?
Yes.
How many more slides do you have? How much longer do you want, just to get a feeling?
Oh, this is my last slide. Excellent.
Okay, very good. Just carry on.
So the idea, ArcGIS obviously is what we call this a platform nowadays. Just like your iPhone or your computer becomes a platform upon which you do things. And the upon which you do things is where it gets interesting, because those tools that I've shown are actually all available. Right? Esri has sort of adopted the open source paradigm for a lot of these things in the application tier. Actually, there's more and more things in the integration tier that are that we make available as open source technologies as well. And so, if we very briefly sort of visit the GitHub site, where we find some of these things. So, for example, I showed you a geoportal server. Right, so that's a repository that's been there for quite a while. We also have some, for example, integration with Drupal. Right, so how do I build my website in Drupal, or actually there's WordPress and Kentico and others. How do I integrate web maps and the map galleries and those nice things that you get when you implement the platform as an organization? How do you expose those through nice looking websites? Right, so that's another sort of feature. And maybe last here before we hand it off for some questions, Coop is a technology. And this goes back to some of the discussions I've heard in Stephen's talk last time. It is really a broker technology where you connect from different sources and expose different sources. Right? They might be commercial technologies like ArcGIS or Safrada or others, and then expose those as feature services, the data sets that exist in these others. And so we're developing some additional of these adapters for Coop. Those adapters are typically open source as well and can be extended upon and integrated into other solutions. So there you have it.
Martin, thank you very much. Let's open this up immediately to questions. We've got maybe 10 minutes. I think we have for discussion here. So we'd like to kick this off.
Martin, have you got any way of confirming the quality of the data that you are consuming from all these different sources?
Oh, that's a very good point. So there is a way. Let me see if I can show that, because that's actually easiest. So, for example, we have actually worked with FGDC over many years, and I don't think we've enabled this yet. So with FGDC, we have actually sort of integrated with what they have developed is a service status checker. And the service status checker is a technology that goes out to different catalogs, and we upgraded this system, so this is an external demo site, and so we have some configuration to do there. Once you've enabled this integration with the status checker, what it'll do, it'll go through all of these services that it finds in your catalog, and it's going to say, I'm going to ping it. I'm going to ping the server. I'm going to issue a get capability request. I'm going to try to create a map. I'm going to parse the get capability response and things like that. So, and then from that, it actually creates a little bit of a store. Let me see what happens. Right. So the idea is that you can sort of integrate with this. Let me do this. So here's a little bit of documentation on our GitHub site that talks about this integration. And so essentially, I was looking for some icons. So what it does as a result of this integration, actually, what you will see for every result is a little phone bar type icon. And the phone bar will either be 0 bars, or 3 bars, or 1 or 2 bars, etc., based on the scoring that comes back from the service status check. And that helps actually users a lot in assessing the usefulness of this service. Right? Will it actually respond? Is it actually up and running? And those kinds of questions, because that is one of the sort of the more frustrating things for users when they go to a network, any network. They do a search, and obviously there will be some matches, and then they go and try to download something, and it doesn't find it, 404 error or something. So yes, there are some ways to assess that, and there are some tools. The service checker itself, I'm not sure where the code for that is. I think it's managed by FGDC or USGS, but it's available to be integrated with.
Thanks, Martin. Other questions?
Yeah, this is Derek. I have a question. Martin, have you looked, or are you doing any work treating social media as one of the data sources to connect to?
We have looked at that. Actually, there is not so much from a geospatial server perspective, but more from some analytical perspective. So we have some tools that are focused on sort of real-time data ingestion, if you will, and that's what we call it our geo-event extension. And let's see, right? So geo-event extension is a standard plugin or add-in for ArcGIS Server, and it essentially you configure it to connect to different feeds, and one of those feeds might be, for example, Twitter. And what you can then do is things like you see here, right? So you can use the social media feeds to understand what are people tweeting about in where. Where is the hotspot of these tweets? Is there any hotspots for that time, right? So for that matter. So yes, there are technologies there. A geo-event extension is a standard part, but as you can see, this Twitter adapter here is another one of these, or connector as they call it, is another one of these open source tools that taps into that.
Very good, and we had recently some very good examples of that to do with forest fires in Europe.
Yes, for example, yes. And so the idea, so interesting there is that the same technology has a capability called geofencing. This would warrant a whole talk about itself, where you could sort of equip, say, firefighters with a little device that tracks where they are, and you can set up safe perimeters around the fire, and you can understand, and the system will trigger when someone enters the danger zone or exits the danger zone, or it spends too long in a particular area, things like that.
But also, whilst it was 80% accurate in terms of geographical location, which is pretty good, in terms of time, it was a warning device.
Yeah.
Which was allowed responders as well. So there's some very interesting research coming at how this is really working. Anyway, let's not get into that in detail. More questions. Let's just keep it flowing. No more points.
Another question,
but you're on mute.
It's Derek. If just a question that might give people time to formulate some more questions. It's not really my question doesn't connect to the core topic you discussed today, Martin. But I'm interested in the idea of serving netCDF files, huge, colossal, multi-dimensional data sets as mapping services. I know that's a little bit away from the core topic here, but and I'm not sure if that's your area of expertise. But how does that happen? And with respect to, I'm thinking in caching for mapping service. We are working. Some of my colleagues here have some netCDF data sets that are measured in hundreds of terabytes. Is serving such things as mapping services viable?
There's someone that could actually speak about that, maybe, that's as a suggestion. That's Peter Becker. He's the product manager for our image server technology. Image server is a technology that is totally designed around serving massive amounts and large data sets dynamically. Right? So these ocean modeler, I mean, these are fairly small data sets, right? But they are actually netCDF files. But it's fairly small because the resolution is very coarse, and there's no depth information, right? There's no third dimension in these data sets. However, the same and what I did here is this overlay analysis is something that is actually done on the fly, right? So there's no pre-cached sort of overlay of calcite and depth in the database or in the data behind this application, right? And that is the strength really of this image server technology. And it can use netCDF and HDF as data sources. It could actually use WCS services as a data source, right? So almost cascading, if you will. And the way it works, it understands the area where you're trying to get some analysis, right? So if I zoom a little bit closer over here, now this loading, it actually redid the analysis. Right, so if I design my model slightly differently, or change these parameters slightly here, every time I run this model, it's going to redo that analysis. But it's smart enough to only do that for this area, because that's what I'm looking at, or that's what I'm downloading, because you can also extract this data out of the image server. So the point is that the image server has a lot of sort of call it meta structures or metadata structures almost, not in the ISO FTDC sense, but in the really knowing where do we have data, what is it, where, how deep is it, and how tall is it, and what is the resolution, and a lot of information like that. Based on that, it can very quickly get a portion of the data set, how large it is, and do the analysis on it. And this is a very simple analysis, but if you look at, for example, the Landsat archive, then those are not so much individually big files, but just the volume of data is very high, right? This is a good example of that. Right, so where you can compare different years of sort of imagery. Right, so Landsat imagery, immediately accessing multiple years of Landsat imagery, doing an NDVI classification using a number of bands, and then on the right-hand side, doing a difference of those two NDVI images that were created before. So that's image server is the technology to do that. What you expose here can actually be exposed as WMS and WCS as well, right? So it's accessible to other clients also.